All right. All right, folks. The test. The test is coming. The test is nearly here. Test 2 shall be conducted in this room at this time next week, July 17th. Any questions about the test? So everyone's going to get 100% then?
I mean, you already released the review, right? I guess the question would be how different is it from the review?
You know, it's a new test. It's not the exact review document. That would be a bit silly.
It won't be a total different concept.
It's testing the same topics, definitely.
Okay.
The coverage of the test is the same. It's not covering different topics, but the questions will be different and varied. For one thing, I use a document generation system called LaTeX to do my tests. So the test is going to look much better than it usually does. For one thing, the code will have syntax highlighting. So at the very least, you'll also have like actual lines to like write on instead of just blank spots.
Okay.
Yeah.
I was going to ask, so the Java test to review the events or the buttons were kind of simple, like changing the value of the text. Like, will the test be similar difficulty, or do we expect something more difficult than that?
Well, I can't really say.
Fair enough, fair enough.
I'm sorry, but one of the things I do not entertain is speculation on the easiness or difficulty of precise questions on the test. This would even be to confirm or deny the existence of precise questions on the test. So, unfortunately, I'm not at liberty to discuss. The other thing that I never ever say about a test is how many marks it's worth, or how many pages it is, or how many questions it is. Because, let me tell you, I can set you one question, 3 sentences, and it'll take you 5 hours. Right? I can assign you a test question that's out of 5 marks, and that'll be a whole test. Right? It doesn't really mean anything. It's subjective with respect to the person who draws the test up. Right? It's like, you know, an inextricable factor is like how generous am I when I assign points to a question intending it to be graded, right? Some profs will say, oh, doing that's worth 2 points. Some will say, doing that's worth 1 point. You know, there are too many confounding variables. It's really not useful information, right? Yes.
Okay, I do have another question about the test, because you offered about asking questions about it. Do you find people generally do better on the second test than on the first test?
No. Sorry.
Oh, I'm just curious.
Yeah, no, it's so the difference between the first test and the second test is that with the first test, if you were astute and picked up like if statements and loops in Python, you can get pretty far on the test, the first test, without having really learned much Java. Test 2, we are no longer in Kansas, Dorothy. So you know, we're talking about inheritance, right? We're talking about arrays. These are inherently more difficult topics. Some members of the class will have sort of, I don't know. I always kind of envision, all right, you know Mario Party games? Well, in Mario Party 5, when they let you know who the winner of the game is, they have this scene where like all the characters are flying towards the camera as if through air, and then they all kind of fly away if they don't win. That's kind of how I think of people making it through Java. So a few people will have not quite made it through understanding arrays. It's a more difficult topic. They won't necessarily have made it through, inheritance. This doesn't say anything about any particular student's performance. But on average, as we go through the course, things get more difficult, and the people who have been, not getting the material, there will be more and more of them as we go through the course. So, typical. Except for this section, which is the exception. Every single person in this section gets every single thing I say, right? Yeah. This is a pretty good section, actually. By my experience in historical standards, we have a pretty good ratio of people who are understanding what I'm talking about. So, yeah. Any other questions? Would you like a test writing strategy?
Sure.
All right. So, my recommendation, when you sit down to the test, before you start answering any questions, take a quick look through all of the questions. Circle the ones that you think are very easy and that you could solve very easily. Go through the whole test, circle all the ones you think are easy, then go back to the beginning of the test, answer all of your circled questions first. All right? You kind of want to think of the test as like a marks maximization function, right? What you want is you have your delay while you're reading through the test, but then you want your amount of marks you're getting on the test to look like that, right? Over time, where this is the maximum number of grades that you can get. If you did that, then you've got quite a good mark on the test, right? So the point is, this early phase of the test is when you should be getting the most marks the quickest, right? This is all the stuff you know how to do, the stuff you can bang out easily, right? The reason is because people have a tendency to get stuck on problems, right? So if you go through the questions in the order that they appear rather than the order of difficulty to you, you will probably get stuck on a question at some point. You're wasting time that you could be using to answer other questions. That's test writing strategy number 2, is be aware of how much time you're spending on a question, and don't fall for sunk cost fallacy, right? Do you guys know what sunk cost fallacy is? For those of you who don't, it's the idea. It's like here's an analogy, right? Let's say I'm sitting at a slot machine, right? Let's say I've put $100 into the slot machine, and I haven't gotten the jackpot. It's like, well, I've already put $100 in. I'm sure it's close to giving me that jackpot. I'll put 50 more in. It's like you have no more chance of getting the jackpot after having put $100 in than you have for the subsequent 50. So, the idea that you've already put this much time into the question, oh, you must be close to the solution, not necessarily if you're stuck on the problem, or if you just fundamentally don't know how to do it, right? Or just it's left you, it's escaped your brain, right? So, be aware of how much time you're spending on a problem, and if you're stuck on a problem, leave it and come back to it later. The way that your brain works is actually like your subconscious mind will be working on the problem even while your conscious mind isn't. So if you come back to it later, you might have a better chance at it just for that amount of time you've put in. So that's piece of test writing advice number 2. Let's see, number 3 would be study. Ooh, I have a. Let me see. I have a comic that I like to show students. Yeah, this is the one. Yeah. There we go. Wait, seriously? You didn't study it for the test at all? I'm telling you, it's fine. I borrowed my brother's cloak of wisdom. You have 30 minutes, plus 10 wisdom. I should have studied. So there you go. And like, if you wanted to talk about like, what stat that would actually be in D&D, that would be intelligence, not wisdom anyways, so he's like equipping the wrong thing. It's not like, well, I suppose wisdom is good if your professor likes to give you trap questions. So anyway, shall we talk about Java then? Java material? Is everybody feeling okay about the test? No? Well, well, you still have a week. You still have a week to get some studying in. Some good, honest, hard studying in. Remember, you should be doing a little bit every day. So, might as well get IntelliJ up and running, eh? So, when last we spoke, we were talking about subtype polymorphism, which is pretty out there as a concept, quite different from the sorts of things you'll have done already. Yes?
So question on the GUI stuff for the test. Because we've been given like templates, will we have to like manually like initialize a stage or a scene, for example, on the test, or would we be given kind of that code?
You will not be required to do anything on the test that was contents of the template. You don't have to memorize the template, no. So, polymorphism then. So I'll go through this again, because this is, you know, it's a little bit to chew on. So, when talking about inheritance, when we say one class inherits from another, class A inherits from class B, we say that class A is a class B, as opposed to association, which is class A has a class B, or has many class Bs, right? When we declare a variable with a supertype, it is satisfied by objects from any subtype. So, one example of this, which sort of exists within the let me see if I can find it. An example of this that exists inside of the JavaFX template. Let me pull up the JavaFX template. Where's it here? Inheritance, there we go. Sample code. Download. That is fine. So, add components to root. What's the line for that again? Root dot get children
Not add or not at all.
dot add all, and then 1, 2, 3, 4, 5, you know, button 1, button 2, etc. Right? So, did you notice that when you were using that thing, these are of different classes? Right? A button is not the same thing as a text field. So how is it that add all can accept any of those different types of things? Right? Why is that? Why does that work? Well, all of the GUI components are inheriting from a common class. They are all subclasses of a particular superclass. If we should have it in the module for that week. Should be in here somewhere. Where's the UML? No. Yes, here we go. So you'll notice label, button, text field, these all inherit from labeled, text input control, or region. Canvas also inherits from a thing that this thing inherits from, which is node. So, if I am requesting a node array, right? I can populate that array with objects of any subclass. So I can say, you know, button, label, button, etc. Right? Now this is like, if this were a loosey-goosey dynamically typed language, Python, JavaScript, PHP, etc., we wouldn't even think about that, right? But Java, right, arrays are monotyped. An array is only allowed to have one type of thing in it. This is the way that Java gets around that and allows you to have heterogeneous elements inside of an array. Because each one of these ultimately inherits from node, therefore can be considered a node because it's a subtype. The subtype can satisfy a supertype requirement. Does that make sense?
So you're saying this is an example of polymorphism?
Yes.
Okay.
So this is a specific type of polymorphism known as subtype polymorphism. Java actually contains several different types of polymorphism. The ability to overload and override methods is also a form of polymorphism. Polymorphic just means many-shaped. It has different shapes depending on its context. This is an example of subtype polymorphism, but we also have a thing that we're going to get into right at the end of the course. Technically a form of polymorphism. Colloquially, you can think of them as type variables, but the angle braces, you may have seen angle braces with a type inside in Java occasionally.
Like the action event?
Yes. Should have an example of this right in here, actually. What if I just search this? Nope, okay. Well, anyway, basically when you define a class, it's possible to say this is a type variable. You need to provide it when you create the type. This is, lists use these. These are called generics. So, give me an example. Array list, yes. Yeah, here you go. So, okay. So, array lists are a thing that we'll be talking about toward the end of the course. Stop that, you. Don't you die on me. Don't you do it. So, array list is a class. It's a collection type in Java, kind of similar to an array, but behaves more like a, you can use it more like a list in another language. You guys, oh man, I might have to talk about the difference between arrays and lists. But basically, an array list in Java is an array in the back end, but it presents the interface of a list. Angle brace, type in the middle. So, in order to create an array of things, you need to know what the type is. String is provided as a type variable throughout the array list definition. This is carried through in order to use it for like the array you're declaring. We don't have to get into generics just yet. We'll be touching on them toward the end of the course. But this is another form of polymorphism that exists in Java. So, but at the moment we're talking about subtype polymorphism. So, in this example, we have a circle, C, declared C. We can provide it a circle object. So far so good, this is what we've been doing this whole time. If we provide a geometric object variable, a circle can be instantiated there. Circles are geometric objects, right? But this can cause problems if you don't know what you're doing. So let's make a new class. Call it class A. Make a new class. Call it class B. Class B extends class A. There we go. Let's give class A public integer A. Let's default that to 10. Sure, why not? Public class B as a public integer B, defaulting to 20. There you go. Oh, that's very small. Let me increase the magnification. There we go. So far, so simple, right? Let's now make a main function. Main, there we go. Give it a public static void main. So B inherits from A. We can say A foo is a new A. This works. A bar is a new B. Also works. The subclass allows us to satisfy the requirement for the superclass. The reason this is the case is that the subclass has everything that the superclass has. When the type, like, what you're guaranteed to have at least all of A in B. So, you know, from the perspective of the type checker, if I go looking for something in A, it's in B as well. So B has everything A has. Nothing's going to be missing if I have a B instead of an A. So, it does not work the other way around. That is an error. So, if A has our int A and B has our int B, then A has int A, but B has int A and int B, right? When we declare Baz with type B, we are saying, I want it to have this stuff, right? If we provide an A instead of a B, something is missing, right? A has no definition for this B thing, which we want to be there by declaring the type as B. Does that make sense? Good. How are you guys like feeling with this? Is this good, bad, or ugly? Good?
It's good. My only feedback, but I totally know like why to use foobar and AP was, I think for me it'd be helpful to use like more object names. Like I like the fruit example, but that's just my only feedback.
Okay. Yeah, we can do that quite quickly. So public class mammal. Mammals have what was something a mammal has?
Wombs?
Sorry?
Wait, never mind. I think wombs.
Well, yes, it
But all
moves.
animals,
All
no,
animals.
wombs, like
Yeah.
WOMB.
Well, fur. Well, some mammals are hairless. Legs. How about vertebrae? Public int vertebrae. Does anybody know offhand how many vertebrae a human has? I have no idea. Let's say 12. We have more than 12. So then class human extends class mammal, right? Humans have things that are specific to humans, such as thumbs. I love it. Int thumbs 2. Very good. We do have thumbs. Other animals have thumbs, but you know, that's why this is kind of a stupid example, because you know, in reality we would have like a primate class that inherits from mammal, because primates have thumbs. We would be a member of the primate class. That's okay. This is good enough for this example, right? So human extends mammal. There we go. Ah, yes, the names are wrong now. Refactor? Rename file? Rename file to A was mammal. There we go. B, refactor, rename. I probably did more work than I needed to. Human.java, there we go. Main. Alright, so mammal, Charles, or no, I'll do my kids. Okay. Felix is a new human, or he's a new mammal. There we go. Mammal, Cordelia is a new human. That's kind of true actually. Felix is a little bit of an animal, but that's okay. He's a boy. Boys are animals. But if we have a human, Theodore, if we want a human, a mammal will not suffice. We want a human. Right? So, okay, sounds good. So now let's try to access some properties. So, Felix, being a mammal, and not a human, even though he is a human in real life, it's okay. He has vertebrae. Let's just print some stuff. He has vertebrae, but because he's been declared mammal and not human, he has no thumbs. But here's an interesting thing, right? If we take Cordelia, she has vertebrae. And question, does she have thumbs?
Yeah.
Yep. She's an object of the human type, which means that she will have thumbs instantiated. But, bum bum ba-dum, boo. Not according to the type checker. According to the type checker, she's not a human, she's a mammal. Why is she a mammal and not a human? Because she was declared as a mammal and not a human. Right? So just because you've been given a human, if you've been declared mammal, then a mammal is all that you are, according to the type checker. This is the difference between compilation and execution. During execution, Cordelia has thumbs. If this statement were allowed to get through to the execution engine, this would be fine. But according to the analysis engine, according to the type checker, this is not fine. Remember that the type checker doesn't execute the code it's analyzing. It can't just kind of like magically, oh, I'm looking at this symbol that was declared as this thing, but I know from previously that it was actually given something else. Like, it doesn't do that kind of analysis. It's like, this was declared this type, therefore it is this type. Make sense? So far so good? Yes.
Are there many reasons you would want to do mammal equals new human then, or is that just something you should avoid?
Again, it becomes a lot more useful when you're talking about collection types, right? You could imagine if we had if we had more than just humans inheriting from mammals, maybe we have humans, gorillas, orangutans, and chimpanzees, right? If we have those four things, if we declare an array of type mammal, we can put into that array a human, a gorilla, an orangutan, or a chimpanzee in any slot, right? It allows a bit more flexibility in that way. The other place that this can come in usefully is the same effect takes place on input and output arguments to methods, right? So let's say you have a method, right? And the input is like declared type mammal. You can throw anything that inherits from mammal into there and it works. And if you return type mammal, anything that's like, of type mammal you can throw out again. Like for example, maybe your method name is transmogrify, and the purpose of the method is to take any type of mammal and turn it into a chimp. You could do that with this method, right? You could take any type of mammal in, and then out comes a chimp. But of course, if that were the case, you would probably want to constrain the output type to chimp, because it's guaranteed that chimp is coming out. Yes?
So if you were to add, say humans to a mammal list, how would you iterate through that mammal list to make sure the human behaves like a human without having to explicitly declare it as a human again? Or cast it as a human again?
Well, I mean, you can take the elements of the list and cast them as the particular types to access the methods specific to that class. But the question is, like the deeper question is, given an object, how do I tell what type it is?
Yeah.
Right? I have to look it up. There's like a type of function. This is in the notes somewhere, but get class. Instance of. There you go. So, yeah, this is definitely coming. How far down is this in this notes? Oh, it's really just right there. Okay. So, using the instance of keyword, we can create a Boolean test to see if an object is an instance of the specified class. So, for example, let's not do all of those, but let's do like one more at least. New Java class. What do you want? Gorilla, orangutan, chimpanzee? What would you like? Gorilla? Okay, gorilla. Public class gorilla. Mammal should really say ape. That's okay. Alright, let's give it public. What property does a gorilla have? Strength, yeah.
Sharp teeth.
Crushing power, because gorillas can crush things.
Sir,
Yeah?
one gorilla or 100 men?
Ooh. Are the humans allowed to use tools?
No.
Are the humans in shape?
Average.
Or are they like programmers?
100 programmers.
I'd have to put the gorilla over 100 programmers, but if they were like 100 like military trained humans, I'd say the humans.
Okay.
Yeah. The gorilla could pretty easily pick us off while we were running away from the gorilla. Yeah. So we have public class gorilla, has crushing power, extends mammal. There we go. So, Oh, and just to like, just to round this one off and show you the solution to that, which we discussed last time, but you know, you have to cast it as its type. So you have to cast as human, but casting binds less tightly than method access, so you have to bind it to the object more tightly using an extra set of parentheses. And then everything becomes satisfied. You guys know casting, right? They did casting with you?
Yeah.
So, let's say we have a mammal array. It's kind of bothering me that it's not primate now, but that's okay. Or ape. Mammal array, friends. New human, new gorilla. I think that works. No, I'm mucking up my syntax. Is it curly braces in Java? It's curly braces in Java. There we go. I am teaching JavaScript, Java, and PHP today, and they all use something slightly different. Not today, this semester. It's okay. Java is curly braces. So there you go. We can declare a mammal array. We can populate it with humans and gorillas. And this is legal. Yes?
So in this case, if you were to call like friends at value 0, you'd be calling the human object there?
Yes. So you could say something like mammal, friends at 0 dot vertebrae. Why are you complaining? S out. There you go. It's complaining because that's not legal. So, friends dot 0 has vertebrae. That's okay. Without casting, you get to the set of common features between all of these things, but no further. What if I want to access some human things? Right? Well, I need to know if it's a human. Right? So we need to be a bit more selective. For int I is equal to 0, I is less than friends dot length I plus plus, ba-boom. Loop! 3 marks on a test just for that. Boom. Less than a minute. If friends at I is an instance of human, S out, friends at I dot thumbs. There you go. It even auto-completes that for you, which is nice of it. You can cast it as you still have to cast it as human because it still thinks it's of type human, or it still thinks it's of type mammal, but thumbs exists, right? Else if instance of gorilla, S out, friends at I dot crushing power. See, now that you've got the instance in there, IntelliJ's kind of figured out what we're trying to do, so it can give us a little more assistance. Does that make sense? Question?
So if you were to upcast the gorilla to a mammal, then cast it as a human, would it get thumbs? Or is a human, yeah, upcast to a mammal, then yeah, cast it as a human.
Let's run this to prove that it works, and then we'll try that. you should think of casting really as I am overriding the type checker. There you can see everything runs. I think Gorilla needs crushing power default set. Let's make that over 9,000. There you go. So it's a very old meme now. It's okay. It was old when it was original. So you want to take it. You want to take the gorilla. Well, downcasting it to gorilla, upcasting it back to mammal, and then downcasting it as human is actually like, that's identical to just casting it as human in the first place, right? So let's just cast it as human and see what happens. Human. And we're looking for thumbs. Bork. Exception. Class gorilla cannot be cast as human. Gorilla and human are in unnamed module of loader app. So there you have it. You get a runtime exception. You have you've overridden the type checker and said, no type checker. I know what's going on. I know what's going on. Don't worry. Chillax. These will work out. It's fine. Type checker's like, I guess you know what you're doing then. Okay, I'll just sign off on it. And then if you don't actually know what you're doing, you get that. Basically, the purpose of the type checker is to try to prevent that from happening. And if you tell it to chillax and it happens, it can happen anyway if you're not careful. Yes?
I might be getting confused, but do we get the same kind of thing last class where they define kind of the bits that you're talking about at the end of class? It's just applied somewhere else, but it's the values don't exactly line up. Is it that kind of thing when you in this case?
Yeah, it's like it's slightly more intelligent than that. It's not looking up memory addresses. Well, it might actually be, but yeah, you'll have to forgive me. I'm a C programmer at heart. So, and if this were in C, if you had the wrong address, it would just read it anyways. But yeah, it's like, okay, here's object, right? We declare it, and it has crushing power, right? No thumbs. Crushing power and vertebrae, no thumbs, right? The program loads this thing, and it's looking for thumbs. It doesn't find them, so it crashes out on an error, right? The thing I have doesn't have the thing I'm looking for. Class cast exception. So, sound good? Any other questions? Yeah, Java is a little more safe than just oh, I'll read that memory for you anyways. But in C, it would totally do that. Did you know that C doesn't do bounds checking on arrays either? If you keep reading past the end of an array, it'll just keep going. It'll just give you all of the memory between that and wherever your memory ends, and then you get a segmentation fault. Yeah, C is great. Everybody should learn C. Actually though. So, good. Any questions? Any other questions? This clear as mud? Yeah? Okay. So what's the point of all this? I've explained a couple of ways that this could be useful. Using like collection types is one way this can be useful. Another way this can be useful is to attempt to reduce the amount of like redundant method overloading you have to do, right? So let's imagine we have this UML diagram, this class diagram. Let's imagine that we need to write a billing method that calculates and prints bills for health club members. Without subtype polymorphism, we have to write a version of this method for each class, faculty, staff, and student, which is like, you know, a person that could actually exist, you know. These will probably have a great deal of repeated code between them, particularly if they only need like information contained in the person class anyways, right? So you can eliminate these 3 overloaded methods and replace it with this one, accepting the supertype, right? You do that, but you don't lose the ability to put faculty, student, or staff in there, right? Make sense? And then if you need, like, for example, if students get like a, you know, a 50% discount or something, you can write a simple little if statement that says, you know, if, you know, if person instance of student apply discount, right? Make sense? Yeah. This method, yeah, accepts all 3 different types. Does that make sense? Any questions about that? Okie dokie. I already talked about this, but again, if you need to store references to objects of all of these types which are inheriting a common type, you can collect that under a supertype, and it reduces the amount of redundant code that you have to work with. Not to mention, like, if the cap here is meaningful, then it kind of, this becomes like actual semantically, this becomes semantically useful. So for example, let's say that the size of the array is the maximum number of registrants that you can have. Let's say like you're giving tickets out to an event or something, right? This is the maximum number of tickets you can give out. Let's say that, you know, like if you wanted to do it this way, you kind of have to decide what the split is here, right? Am I giving like, you know, 20 tickets to faculty, 40 to staff, and 40 to students? Am I, you know, giving 5 tickets to students and the rest to faculty, you know? You have to make that decision. Whereas here, you don't have to make that decision. You can just say, there are 100 tickets, I will take people of any type to populate this array. I don't have to decide how many of each particular type of person. Does that make sense? Good. Any questions? Okie dokie. So, let's take a look at some of our exercises for this week. So, let's do this one. We've got 3 classes: vehicle, car, and truck. please implement the vehicle, car, and truck classes in your Java projects that you have open. Vehicles have horsepower, a constructor, racing speed, get horsepower, and then also a race against method. If one vehicle's racing speed is greater than another vehicle's, then it wins, and you return true. So, a car has a racing speed that's half its horsepower. A truck has a racing speed that is 1/3 its horsepower. You can see that both the car and the truck have, well, they have constructors, but they also have one method, get racing speed. Make sense? Coder up!
Racing speed. Is that greater or? So this is get racing speed.
So it's never stored anywhere, it's calculated on the fly from horsepower. Can I give everyone some free advice? Like career advice? Everyone in this room intends to make a living with a keyboard. You should learn to use them properly. Alright? If you're using 2 of your fingers to do the keys on the keyboard, you are working at 1/5 your full efficiency. So there are things called typing. There are programs you can use to learn how to use all of your fingers on the keyboard. It's called touch typing. It's perhaps an archaic term, but touch typing is that's the technical term for it. You can do online things to. This is the one I usually recommend to people. Get out of here. Get out of here. There you go. and it's just like, don't look at the keyboard and type that, right? Right? The whole point, though, is that you're able to type without looking at the keyboard, right? And basically, if you intend to make a living at a computer, you should, you should learn to use the tools that you have available to a great degree of efficiency. Yes.
Thanks for that. I just noticed that the module 10 for week 9 isn't available, like isn't published or
is it
visible.
not?
Thanks. Like I don't see it. Oh yeah, there we go. Okay.
Boop. There we go.
Thank you.
And since we got the test coming up, I'll release solutions for past week's exercises now. Solutions. Alright, solutions are up to now.
I have a question. It's okay if the answer is no. Would you be willing to make public the next assignment? Because I'm assuming the next assignment probably has like inheritance stuff on it, and it might be beneficial to work on that as test prep. Thank you.
Consider it done.
Thank you very much. Again, just if we're
Would you like me to do the introduction for it?
No, you don't have to. Like I you've already done more than I thought you would, which is just simply making it visible because I figured this might help. But you can.
It actually, it's got stuff in it that we haven't quite gotten to yet.
That's fair.
So, but you can, yeah, I don't mind showing you.
I figured that'd be for like the crazy people like me who kind of want to check it out.
Yeah, well, I mean, it's not crazy to want to get a head start on things. That's just good planning. So, I'm honestly not sure what it's even doing in that week, given that it requires the stuff that we're doing this week. I think maybe it got in the wrong slot. So, shall we take that up? So let's make a new class, Java class, vehicle, as they say in the States. Car, truck. So, the vehicle class, going back to our thing here. There we go. Vehicle class has private int horsepower. That's not a method. What am I doing? There we go. Needs a constructor. Constructor. Boom. Needs a getter. Getter. Boom. Now we have a get racing speed method here. And we kind of like it kind of doesn't make sense there to a certain extent. Don't worry about it. We're getting there. Public int get racing speed. Return -1. There we go. And race against. Public Boolean race against vehicle V. if this dot get racing speed is greater than v dot get racing speed, then return true. Otherwise, return false. You guys want a quick tip to try to condense your code?
Sure.
Anytime you're doing if assign or return true then false, you can always abbreviate it like this. Return the condition itself.
It doesn't need the brackets?
Nope. I mean, you can put them in if you're superstitious, but yeah. I was a Haskell programmer for a good number of years, so I'm very superstitious about braces, but yeah, so that will do. So there's the vehicle class. Let's do the car class. The car class extends the vehicle class. We've got a constructor. There you go. Binga banga boom. We get public Boolean get racing race against. Oh, look at that. Not bad. Or no, I'm sorry, not race against. What is it? It's get speed, yeah. Public get racing speed, there we go. So this is where you want to do something else. You just want to say this dot get horsepower divided by 2. Question? Oh yeah, certainly. Better?
Yeah.
Question?
On your vehicle class, shouldn't you be returning horsepower for the get racing speeds of -1? Since it says the racing speed is equal to its horsepower.
Oh, does it say that?
Yeah.
By default, the vehicle's racing speed is equal to its horsepower.
Ah, okay. Alright. There we go. I was trying to make a point. It's a point that'll come up later. Truck. Trucks are similar to car. Wait, I have to use my truck voice. Trucks are similar to cars. Insert truck constructor. Oh wait, doesn't extend it. Extends vehicle. Yeah. Truck constructor. We're also having to override. The other one, what's it called? Get racing speed, yeah. This dot get horsepower. Divide by 3. There we go. Okay, next part. Now create the vehicle test class. The static create method will ask the user what kind of vehicle or car or truck and what horsepower, and then creates the appropriate object and returns it. The main method calls create twice to create 2 vehicle objects, and then races them and announces the winner. So it's a little bit of like do stuff in the you like have print messages. This one has print messages. Do part B, please. 5-10 minutes, maybe. If anybody wants to see any of the other classes, vehicle,
The car,
the car.
please. Thank you.
The car is the same as the truck. It just has a different number here. What part do you need? That's most of it anyway. Remember, folks, clarity is always worth the space. You'll need your wits about you on the test.
Should the printings be in the create method or in the main method?
Both. So what this is, this is like a sly way of introducing a new design pattern called a factory method. So, like, yeah, we're taking the portion of the code which creates the vehicle and prompts the user for that stuff, and we're encapsulating it in the create method.
Is this sort of one circuit page or like passenger like page, and then I have people there, so don't put anything in the create method, but I wanna like say like if you answer car, I'm gonna create an instance of car. If you answer truck, I'm gonna create an instance of truck.
Well, the specification says the static create method asks the user what kind of vehicle, car, or truck. So that question, that scanner should go inside the create method.
Oh, it shouldn't be in the main then.
No, it should be in the create method.
Okay, thanks.
Okay, this one's a little long, so I'm gonna start working on it too. New class, vehicle test. We need public static vehicle create. And we'll need a name. Vehicle A is equal to create. Vehicle B is equal to create. Then, on your marks, get set, go. If A dot race against B, S out the first vehicle 1. Otherwise, the second vehicle 1, which is kind of like, is it the second vehicle you entered or the vehicle that came second in the race? Because if it's the second vehicle in the race that won, then that's not a very good race, is it? It kind of defeats the entire purpose of a race. It's like racing cars, but by golf rules. So, on to creation. But you see how like I could lay out a whole procedure in main without having to worry how these vehicles are being created. That's the whole point of encapsulation. We are separating our concerns. So, creating a vehicle. Car or truck? How's this work again? Scanner. Review scanner. You have to specify system dot in. String response equal to new or is equal to scan dot read
Next
scan
line.
dot next line. If response dot equals, you can tell I didn't teach the first half of this course, right? Car. Then return new car. Maybe, you know, we'll do other stuff too. Else, if response dot equals truck, return new truck, it'll need something else as well. Else, S out. Looks like someone can't follow instructions. Return null. Boom. That shouldn't cause any problems later. We also need to know the speed. So it's out. Horsepower. Int HP is equal to scan dot next int. HP. I think that'll work. Shall we run it? All right. Vehicle test. Run. Car or truck? Car. Horsepower? 9. Truck. Horsepower? A lot. The second vehicle won. There you go. Looking good. So the whole point of the let me just point out the polymorphism. The polymorphism in this example is residing in the return value of the create method. We are creating either a car or a truck, but both are acceptable and satisfactory to Java's type checker. Make sense? Okay. Good. So now let's use this as a jumping off point for the next thing we have to talk about. That was supposed to go all the way around my neck. That's unfortunate. So this is kind of a point that we touched on when we were talking about inheritance the first time. Some classes make sense as an object, and some classes don't. Right? It's also true that not all methods make sense in all classes, but we could still have reason to put them there, right? It is true that all vehicles should have a definition for racing speed. But does it really make sense to have a vehicle, right? Could you build a vehicle, just a vehicle, right? Not really. Your vehicle will be either a car or a truck or a motorcycle or a bus or a plane or a rocket ship or whatever means of conveyance. The category vehicle is too abstract to have like specific instantiations, right? Same thing with mammals, right? There's no such thing as a mammal walking around in existence. Mammal is a category. It's a category of things that do exist, right? There are many examples of such categories. Most of the words we use are categories of this type. To some extent, there's no such thing as a boat, right? All boats are sailing ships or cruise liners or tanker ships or cargo ships, right? And even if you take something like a cargo ship doesn't really exist as a thing. It's a category of a bunch of different ships. You eventually drill this down to the level of the individual ships themselves, right? This is a ship right here. Clunk, there you go, right? So eventually, all of these categories drill down to physically existing objects, right? But, in our context, does vehicle, is that something we would want to make an object out of? Not really, right? We want to be more specific than that. So our first entry point into the idea of abstract members is this idea that a method like get racing speed, we want to obligate all subclasses, all children, to have this thing, but it doesn't necessarily make sense that we have it, instantiated. What we can do is we can declare the thing abstract. Public abstract int horsepower. It's instantaneously complaining because abstract methods are only allowed in abstract classes. So, when we declare a method, or when we declare a class abstract, what we are doing is we are saying, hey, this is a category, I never want an actual object to be made with this. Make sense? So, once you do that, though, of course, things have to be fixed. So an abstract class doesn't, we use a different word when we are deriving from an abstract class. We don't use extends. We use implements. There we go. So now, class car must either be declared abstract or implement abstract method get horsepower in vehicle. So when we change a class from being a regular class to an abstract class, we are no longer we're like an abstract method is an obligation to the subclass, please implement this. You must implement this to be an implementation of me. So abstract methods don't have implementations themselves. So they don't have bodies. Oh, I did the wrong one actually. I meant to do this one. Get racing speed was supposed to be abstract. There we go. Sorry. So when you declare an abstract method, it's not allowed to have a method body. You're not like your abstract class, you're not supposed to ever have an object of that type instantiated, right? So it has no means of calculating it. The instance variables will never have values just inside of this class. So, so it goes. So, let's go here. So let's take, where are we here? Where are my notes? There we go. So, another good example of this is our geometric object class, right? We've said before, like geometric object, it doesn't really make sense that it should exist as its own thing. Like there's no such thing as a geometric object that isn't a circle or a square or a triangle, etc. So, the geometric object class is a good example of of a class you would want to make abstract. Basically, in more practical terms, when you make a class abstract, you are saying to Java, listen, if anybody tries to make an object of this, slap them on the wrist, or slap them in the face. Because this is not allowed. This is a thing that should never be an object. The way that we represent abstract classes and methods in UML, and it's a little bit tough to see in the diagrams, but can you tell me what the difference is between that text and this text? It's italics, that's right. This is italicized, so that means it's abstract. Okay? This method is italicized, so abstract. Only abstract classes can contain abstract methods, right? You can't put an abstract method in a class that can be instantiated. That would allow you to create an object with a method with no definition. And you can't have that. If it's an object, all of the methods must have definitions. But because abstract classes you can't make objects from them, they're not required to have definitions for every method. But objects which are made from things deriving from that class must provide those definitions. So the abstract method is a way of obligating everything inheriting from you to have that method, to provide that interface. Does that make sense? Somewhat? Any questions? So, Abstract classes are defined just like regular classes, except they use the abstract keyword. Some of their methods may be abstract, so it allows you to make methods abstract, but it doesn't require you to make methods abstract at this level. There's actually one step further, and that is an interface. An interface in Java is an abstract class where all methods are abstract. That's what an interface is. So, yes?
I have an annoying question. Is this stuff like abstract classes going to also be on the test?
Not the test next week, no.
Okay, thanks.
Yeah, this is, we're gonna save this for the exam. And that's not an annoying question, that's a good question. Generally bad practice to put on a test something someone's not seen on an assignment. With the exception I'll make for that is like the material in like the last week or two of a class where there's literally not time to give you an assignment on it, but like if it's not on the exam, then people just skip the last 2 weeks of class, so, you know. Yeah. Good. So, so going back to this code, let's see if we can clean up the errors. So, I may have made a mistake. I think maybe implements is only if it's an interface. Pardon me. You still use extends for abstract classes, but once it's an interface, you use implements instead. So there we go. And with that, I think this was supposed to be that's static. There we go. I think that actually makes everybody happy, doesn't it? Yeah, everybody's happy now. So that's actually all of that was the complete procedure. I just had the one thing outstanding. So one thing to notice. I know that it's probably difficult for you to see from the back of the room. Perhaps you can see on your own computers. The symbol has changed for the class. Abstract classes are a little C icon with 2 gray bars on either side of it. This is an IntelliJ thing. This is to visually distinguish abstract classes from other types. But now that the vehicle class has been abstracted, if we were to try to say, vehicle C is equal to new vehicle, it's giving me an error. Vehicle is abstract and cannot be instantiated. So there you have it. Once you've made it abstract, you can no longer create an object for it. The only purpose of abstract classes is to provide things for the classes that inherit from them. Does that make sense? They don't exist in their own right. Or they don't exist for their own benefit. It's kind of like how you feel when you're a parent, You don't really exist for your own benefit anymore. So, any questions about that?
So when I did vehicle C equals new vehicle, I think tab, it gave me like an override for that abstract method. So I can,
An override for the abstract method.
yeah, so like it filled the vehicle C equals new vehicle, I put 100 horsepower, and it's at override public int get racing speed return 0. Like it just filled that in.
Oh, that's because you opened it with you opened a curly brace there, or maybe it opened it for you, but, yeah, so what it's doing is it's actually, it's creating like a new in-place object that's providing the missing abstract method definition, which is a little strange, I don't think it would really be able to do that.
Well, that's what it's, yeah, I don't know if it was like someone picked the abstract class and the abstract method was not allowed on this.
I don't know what that means,
That, it's, if you hit tab before you do the opening close bracket, then it doesn't do it. Try it. But afterwards it does.
I've misspelled vehicle. What is it?
Public int get racing speed. And then return 0. Then you have to pass the vehicle value in, and then you have to close it off with a semicolon. And then type checker right away.
I've been lied to. Oh, because this is happening after that. Here, let me pop this up. There, see. Now, isn't that strange? So it's not an object of the vehicle class. It's created a new temporary class inside of the vehicle test, like class namespace. It's a don't do this. Don't ever do this. Don't do not. Don't do it.
Hit tab and maybe something. I feel like I should be getting this.
Yeah, I don't know what strange magics these are, but don't do that. That's I don't think this technically makes me a liar or makes the course notes a liar. This is not an object made from the vehicle class in that sense. It's like creating a new temporary class, inheriting from that probably, and naming it something that like is this an anonymous class? I feel like this is an anonymous class. This is a class in the same way that a lambda function is a function. You know? Something like that. Good grief. Okay. So let's take a look at interfaces then. We don't have much time left in class, but if you understand the idea of an abstract class, interfaces are not much more of a leap from there. So an interface is just an abstract class in which all of the elements are also abstract, right? So it's not allowed to have any implementations. When you say this is an interface, you're saying this thing, anything inheriting from this thing must provide definitions for this, that, and the other. So here's an example. and this is how you write an interface in UML, by the way. Let's say we have an animal class. Chicken and tiger are both inheriting the animal class. We have an edible interface. Chickens implement the edible interface, which means that chickens are required to have a how to eat string, a how to eat method. How do you eat a chicken? After it's crossed the road. Why did the chicken cross the road, roll around in the dirt, and then cross the road again? Because he was a dirty double crosser. Fruit are not animals. Does not extend the animal base class, but implements the edible interface. So here's another neat little trick about interfaces. Do I have this a little further down? No, I don't. In Java, every class can extend at most one other class. But you can implement as many interfaces as you like. All an interface is it's binding you to provide a set of methods, right? So you can make as many obligations in that direction as you want. It doesn't actually change your state. Whereas inheritance in the proper sense does change your state, right? Yeah. Does that make sense? We will revisit that topic next week. Well, not next week actually, because we got the test next week. So Tuesday is a big fat review session. All right. Normally I go through the practice test that is that's published on Canvas, and we like do a mock test writing. That's usually the way I do it. You know, I'll give you some time, you work on the question, then I give you the answer, type thing. People usually find that helpful. Then, of course, next week at this time we will have test 2. Any questions? I will open this meeting to motions from the floor. If anybody wishes to propose a motion, yes?
Can you clarify any kind of what we'll be doing with arrays, or just kind of anything that's in the notes is fair game? Creating or rearranging an array or anything like that, or?
Well, the types of things that I could ask about arrays, certainly creating, certainly reading out of them, certainly writing into them. At this level, at this point in the program, I would expect an A student to be able to handle a doubly nested loop algorithm on an array. So that's a program that does look back, or does some kind of swapping, that sort of thing. Does that make sense? So yes.
I have a question. Will polymorphism be on the test?
No. The whole topic is verboten. Yeah. So do your studying on the week 5, 6, 7, 8 material. I think week 5 is the test. 6, 7, 8. 4, 6, 7, 8. Make sense? Do I hear a motion from the floor to dismiss class? Anybody? Anybody wish to make a motion? I hear the motion. Do I see a seconder? All right. We have a seconder. All in favor of dismissing class say aye. All opposed say nay. The motion carries. I'll see you next week.
You might have gotten an email from Ryan.
Associate Dean. Yeah.
I don't know what you need.
Book something with you guys. For the week after. Yeah, but if you can make that like Monday. Are you gonna be back the Monday after the exam? Yeah.
They've got their big course.
Well. Either way, okay, book something with this afternoon, I would prefer closer to the end of the week, it'll have to be your schedule. Well, the thing is, like, I don't have, like, have you read it? That's what the test said last one. Have you ever done it? Okay, so, just go to them. You need to book an
I tried to create something like
they will help you fill out the form. They will email the form, I'll say yes or no. And then that creates the agreement. My responsibility is to give them the test before you write it. And then you go at the time, they'll show you a bunch of tests. They'll give you your exam, they'll tell you the hours. I will be available. I'm available by phone. And if you have questions, or same, yeah, same. Only if you want to write to exams. Well,
It's something that might happen.
If I were you, I wouldn't book it. It's up to you.
Okay, and in terms of, I'm assuming they can, we're still gonna be,
It's a review.
it's right here, it's a review. So it's not like that. Get at Alright, so I'll try to look at more reading, so,
The testing center people are very nice and they know exactly what they're doing, they'll be able to help you, guide you through the process.
alright, I'll really get into it.
Sounds good. No trouble.
Now I feel like I actually, oh yeah,
I have no.
oh, and I feel like I can actually breathe now. Like 10 to I gotta keep looking for everything to add. I was only looking at this sheet.
Basically just go through the manual.
Yeah, I tried to spend very, very little time on that. It is.
Sign that for you,
Yeah,
say.
I'll stop later. I'm more like concerned about Java and
I
Java.
can see.
Did you take a look at the math assignment?
So, it's like 3 days. tomorrow.
one with the video.
Yeah, and then,
I didn't finish the last assignment, so if you could, if 2 days.
But yeah, I got really into games for tablets.
yeah,
Like, it was
but
like
so,
surprisingly addicting.
Yeah, it's a lot of fun.
Yeah,
shoot me
and
an
it's
email
just
to
fun, like,
remind me
the phone
to open the
and
Dropbox for you
Yeah.
and get it in tomorrow.
Yeah, definitely. Thank you so much.
Hey, it's a
Have a good rest of your day.
You too.
I just wanted to talk about some of the stuff on like course nominated. What did you get on yours?
I think we got 1 mark, 2 marks off.
I was wondering if it is text